Howdy everyone, my name is Darshil Rajada and today I'll be presenting milestone 3 of our ISTM 622 course Advanced Data Management. This milestone is focused on MariaDB replication and clustering fundamentals implemented for our project AetherMart, a fictional e-commerce platform. I think the main purpose of this project was to build a highly available, fault tolerance, and scalable database environment, and something which we can support continuous business operation and advanced analytics without any downtime. So yeah, let's get started. So our project overview, the goal was to move beyond a single database design and establish data redundancy and real-time synchronization across multiple servers. So in milestone 3, we focused on two key approaches, a standard asynchronous replication and Galera synchronous clustering. These two approaches complement each other. Replication offers performance and speed for analytics, while clustering ensures consistency and zero data loss. So both methods are essential for modern e-commerce system that serve millions of users, and like it's must to handle a transaction 24 by 7 across all the channels. So yeah, that's what mentioned over here. And in e-commerce, like just to explain a business context why availability matters is basically in e-commerce, every second of downtime affects customer trust and also directly improves and impacts revenue as well, right? So highly availability isn't just about technical reliability, but it's about the business necessity as well. Like nowadays, for or even if we talk about for Ethermart, maintaining constant database uptime means customer can browse through all the products, place orders, and process payments smoothly without any interruption. And even during peak hours or unexpected outage, it happened very smoothly. The experience matters a lot, and it also ensures our analytics and recommendation engines continue running, providing real-time insights to teams like marketing and logistics. So that's what I mentioned over here, like 24 by 7 uptime, and even a few minutes of database downtime can cause like a loss of order. You might lose a customer, product inconsistency, and analytics delays, like marketing and product teams seeing outdated metrics which are not updated and can cause based recommendation for the further product update. So Ethermart's customer base and product catalog are growing exponentially, like 3 million plus product and 500K active users. So there will be a large volume of order and data, and specifically in this context, let's say Alex Keem, who is the CTO, so any technically like hiccup directly impacts our brand and customer trust. So yeah, this is very important. And let's get started with the asynchronous replication. So here we set up a primary server, right? The goal was to keep one database as the authoritative data source, while a second replica continuously mirrors the update. And in this particular business case, when user place an order through a mobile app, right, the primary servers record all the transaction in both order and order items table. The replica servers immediately reflects update, and which will allow report generation, failover safety, and basically it will enable binary logging on primary, and it will create the replication user as well. Like in my case, I have created a replication underscore Darshil, which I'll show you on the actual AWS EC2 instance in just a moment. So yeah, after you configure replication user, it will enable logbin and using the change master to command to connect to the replica to the primary, right? And for business case, like as I mentioned, a customer place an order, like the replica will continuously mirror, and it will allow for all the stakeholders to monitor and quickly switch over if anything happens. So yeah. So before we go to failover, let's now go to the document and let's get started. Okay. So, first of all, we're gonna set up the security group for the application, right? We're gonna do like name replication for the clustering, right? and we're gonna set up SSH as a type of inbound rule which with the custom 0.00. First we're gonna create this security group, right? And then we're gonna come and edit it, and in the editing a new inbound rule, we're gonna mention MySQL Aurora with the existing security group, one which we have just created, and we're gonna save our rules, nothing to do in the outbound rules. So after that, it should show as an updated security group like this, right? The SSH with the IPv4 TCP and port 22, and MySQL Aurora with the existing security group source TCP C306, right? Then we're gonna set up our two instances. So we're gonna name as an M3 replication and two instances, and then we're gonna once the two instances are created, I put like a dash after that because we can go ahead and after that we can add it and put it like dash A and dash B like this way, right? Primary and secondary, and we can edit it. So yeah, and we're gonna select Walkie as key pair. We're gonna select our existing security group which we have just created, right? Firewall in the network setting, and then we're gonna add the MariaDB script which Dr. Gamilian has given on the canvas, right? And then on the once the instance is launched, we're gonna run this command to go to a MySQL and MariaDB conf.d directory or file. Like after coming to the root user, if you just do cd/etc and you list all your directories by ls, you'll find MySQL, and under MySQL there is MariaDB conf.d, right? And under my MariaDB conf.d, you list again all the directories, and we'll have to edit this 50-server.cnf file, right? So we're gonna go into that file, and in that on the primary one, okay, we have set up two instances if you have remember. On the primary one, sorry, we're gonna mention server ID 1, log base name master 1, and bin log format mix. This you'll find on the MariaDB official, uh, like documentation user guidelines. This is you'll find it, and we'll have to comment the bind address. So this is must thing, don't forget it. And then we're gonna save the changes, right? We're gonna restart MariaDB, systemctl restart MariaDB, and then we'll create our user, right? We're gonna create the user. You can give it any name. I have mentioned replication underscore Darshil, and then you'll password as it is given on the official documentation, and then we're gonna grant all the access permission to this particular user, right? And then we're gonna it will say hey, query has been executed, and then we're gonna check our master status. So it should show that the file and the position allocated for this particular user after coming to MariaDB, right? And then yeah, that's what I mentioned that after that we switched to the replica and updated the config file there as well on the second server. And over there we'll have to mention server ID 2, right? Because the one is for primary. And then we updated the master. So over there we'll have to mention again on the secondary server replica, we have to mention change master to master host. This is our primary replica's IP address, right? Dot 172.31.19.63, right? This is what I mentioned. Then the username replication underscore Darshil, the password which you have selected, port will be remain as it is 3306. This is our file name and the POS, right? The file name and POS, the one which you got on the while doing this one, right? While doing this is I think the new one, so that's why POS is different. Again, it's changing like every second as soon as you run the operation. So POS will be the at the time when you have did that show master status, and connect retry attempt will be 10, which is by default come from the documentation, right? And then once this will be done, you again start the replica, and then you check the status of replica. So then it should show like it's running. How will able to identify? So the slave IO running and slave SQL running should be yes. So as you can see over here, right? And again, we can do a demo as well. So by default there is four uh, databases, right? You can see like by default there is four databases. If we say show databases on before creating, this is after I have created. There is four database information schema, MySQL performance schema, and SYS. So now I have created on the primary create database Darshil underscore M4 and I say show databases. So on my primary, it does show that Darshil underscore M4 has been created. And now if I'll go to my secondary, you can see like it was not there, and after that I selected show databases, I performed it does show Darshil underscore M4. So that means the replication has worked correctly and it has been performed successfully, right? So yeah, it is working. Now we can perform some of the operations just to make sure on the AetherMart database, right? So this is just I have, from the milestone to have selected all the customers just to see whether it's coming all the data correctly with the cleaned and transformed, right? So yeah, it working correctly. I have did it on primary. I'll show you. So you can see all the data. Select star from products limit 100 is coming correctly. Then select star from reviews limit 100. All the data is coming correctly with the clean column. That means yeah, it's cleaned and transformed data. So now we can go ahead and perform our all the operations for the synchronization verification, right? So first of all, we're gonna verify and see whether our counts are matching or not. So on the primary, you can see like I have did all the counts from the AetherMart, like for products, customers, orders, reviews, all the tables, row count, and I have checked whether it's matching on both primary and replica or not. Yeah, this is the yes. So that means I have already shown you it's working, and I'll show you so you can see the counts are matching 50 products and 100,000 customers. So the same is showing over here, right? 50 products and 100,000 customers, right? So yeah, it is working now. That means our data has been synchronizing correctly. Now we'll verify the data content integrity. So to run on both the server, and we're gonna check whether our checksum is matching correctly or not. So you can see like both the product like on both the primary and secondary, our checksum is coming exactly as it is. Uh, for all the tables, product, customer, orders, right? So yeah, that's what mentioned. If checksum doesn't match, that means your data is inconsistent, right? So yeah, now go to a real-time replication testing. So we're gonna perform some insert, update, delete. I'll just show you directly on the primary and replica. Okay, so you can see I have performed an insert query for the products table for the product 999. Replication test product is the name of the product, right? Then I have again inserted one more order as well, again 999, right? And we're gonna see whether after inserting is it showing over here. So you can see 999 replication test product, that's what name over here. So it is coming correctly, right? So although we have inserted on primary, you can see now it's showing on secondary as well. The order which you have updated is also showing it, right? So that means it's perfectly showing. Now we'll try and do some update and delete as well. So yeah, let's go and we're gonna perform some update. So you can see I have tried to update a customer city to Austin State, Texas for the customer ID 999, right? And I have tried to update one product price 79.999 for the product ID 99999, right? So if I'll just show over here, you can see on the secondary replica, my product which I updated, it's showing over here. And for one customer ID, Kevin, I have updated city, Austin, and state, Texas. So as soon as I run a select query, for that customer, show me a first name, last name, city, state, it does show over here. So although performing on insert on primary, it's showing over here as well, right? Now we're gonna do some deletion. So cleaning up a test data. Uh, so I have run some delete queries from reviews. I have deleted one review for the review ID 99999. I have deleted order and I have deleted, you know, like order items as well. So you see it says query okay, one row affected. That means it does deleted. And if I'll as soon as I see over here, right, it like select count star from that particular order. So should be zero, it's showing one. That means it does deleted correctly as well, right? So yeah, that means our insert operation replication is working correctly. I have shown you already verify the product existing for the update and delete as well, right? Now, yeah, the next part is for the failover, conceptual failover testing. So before I show you over here, let's go back to the PPT. So what is failover simulation? So that's how we are ensuring our business continuity, right? That let's say a scenario, the primary server crashes during a weekend sell, right? So in that scenario, we're gonna follow the steps that enable read-only mode in primary, waited for the replica to sync when reintroducing the original primary, right? So what we are basically doing is that uh, the primary setting up the primary to read only mode to freezes right and waiting for the replica to fully sync, verifying seconds behind master is equals to 0. The third step is promoting replica to become new primary. So after the switch, all new orders continued processing, and dashboard stayed as it is operational and the business faced zero downtime. So once the original server was repaired, we again restored replication back to normal, proving the complete recovery. So this will be the business impact that order continuously processing with zero downtime. Marketing dashboard, which is Maria's team, like a marketing operations team, will stay operational and fully data recover even if there is a downtime or primary server does not work. So that's what I have performed. I'll show you again over here. So let's go back to the primary. Okay. So I have done set global read only on and set global read only off. Okay. And now let's go to secondary. As soon as we did set global read off, okay, you can see over here, I have direct after doing it on off, I have stopped replica, I have reset replica, again over here it's off and this has become my primary. This is not read only. Even I can insert products, uh, like and do an insert update operation over here. You can see I have insert into products, product name, price, category and supplier ID with the value, and I can as soon as I fetch that product, select star from products where product name is equal to failover test product. That was my value, right? So I have inserted into same secondary and it fetched correctly. That means failover testing it's working, right? And I have performed deletion as well, delete from products where product name is equal to failover test product. Again, one row affected, it did work correctly, right? Now we're gonna again do show master status. Will get our value, what is the file name, what is the position name, because we want again back to restore, right? We'll have to make primary as a primary and replica as a replica. So we're gonna stop our replica to become primary, and that's why we have again did secondary to become a replica. So as soon as we got a show master status, we got the file name and POS. That's what I mentioned over here. And I have again did a start replica. And you can see slave to running and slave SQL running and slave IO running both is been yes. So that means the secondary has again become a replica. Okay. So that's what the failover testing is. As you can see over here, it again became yes, the screenshot. Now we're gonna do a data consistency validation after failover testing. So this is how we're gonna, comprehensive consistency check and run on both servers after failover, whether our data is still consistent or not. after failover has been happened, and we are again restored data back to primary and secondary as it is. So we're gonna check the counts from products, customer orders, right? So you can see I have did it over here, and check type data consistency check product 51, customer 100,000, orders 100, like 199,000, whatever is it, right? And I'll gonna just show you over here both the data is matching or not. So you can see 51, 100,000, 200,048 and 1500. So the exact data is matching over here. So that means even after failover, it has been restored correctly. So our data consistency validation has been checked. Okay. So by this, what we have completed is that our replication status shows both Ion SQL running. We have validated our records counts matching. We have did a checksum. We have performed insert, update, deleted. We have did a complex transaction as well. We have performed a failover procedures, and after failover, we have performed data consistency uh, after failover simulation as well, right? So yeah, this is very important to check whether all things are matching or not. Let's go back to a PPT and we're gonna see our summary. So this is what we have, did our analysis. The replication system successfully demonstrated redundancy, fault tolerance, and near real time synchronization. However, we observed a key trade-off because it's asynchronous. There's always a slight delay between the primary and replica, especially under heavy write loads. This limitation led us to explore Galera clustering while provide synchronous replication for, mission critical data as well. And we're gonna do some advantage and disadvantages. So basically, advantages like it's simple to configure and maintain. There is less hardware intensive, excellent for read heavy workloads like analytics and dashboard. And disadvantage includes like a replica can lag behind the primary, and again, it's not suitable for order processing and financial transaction. So while replication improves reliability, but it's not ideal for real-time consistency, which is why we transition to a Galera for the next phase, right? So that's what mentioned all the advantages and disadvantages, specifically for AetherMart impact as well. That for advantage will be like there will be faster checkout during sales. Maria's team, which is marketing team, can run analytics without affecting orders, and then simple scaling, right? Even if traffic grows, and the risk is like there might be overselling, inconsistent inventory, you will might lose a transaction, and on busy Black Friday, Thanksgiving, or on weekend sales there might be a downtime and you'll lose a major revenue. And that's what I mentioned some in terms of Ethermart replication over here as well, that minimal write performance, that means primary server does not have to wait, like fast order processing, Black Friday traffic spikes, right? Low operation overhead, and 40% cost saving versus synchronous replication, right? And business continuity protection. But the actual disadvantage will be like, you know, let's say on 10 a.m. customers logged in, right? He checked it showing 5 units available at 10:00:01, right? Just after 1 second, customers buy on primary, not on replica, right? On primary, stocks is now zero. Okay. On third second, replication completes from 5 to 0, and on again on 2, but the first customer attempts to purchase, so he'll get to know on checkout, or even after checkout, if might have checked out, right? After then he'll get to know that hey, your purchase has been failed. So this might turns into a customer frustration and potential overselling as well. You like after it already bought, you have to say that it's not in inventory, the your order is delayed, you'll get it after this many days, right? So yeah, that's a major business impact. You might lose data, right? Again, the same example, that customer place a $5,000 order, primary commits it, Then again, after a second, primary server crashes before a replication, and just after another second, last replicated position was 30 seconds ago, right? So result again, order data lost, customer charge, but no order has been recorded, and there might be a financial discrepancy, customer trust damage. So yeah, these all are fail failover required application complexity. These all are disadvantages. So yeah, let's now move to a Galera. So yeah, this is based for again, yeah, before going to Galera, asynchronous replication is based for product catalog browsing, customer profile views, marketing and analytics queries, but it where you'll have to avoid so anywhere when the payment processing comes into the picture or inventory synchronization or some might be security operations or where patients healthcare PHI HIPAA comes into the picture, you'll have to avoid it, right? Okay. So yeah, now let's go to Galera cluster. So overview, basically in Galera cluster, why we move beyond replication. So in Galera, replication provides redundancy but not true high availability, right? AetherMart needed zero lag synchronization between nodes, automatic failover and self healing, supports for multi-region scaling in the future, and supports multi-region scaling, right? So we're gonna set up our cluster for that. And Galera clustering is critical for real-time transaction operation, and this combination delivers speed, scalability, and zero data loss, right? So we'll have to let's go to the clustering. Before that, let me explain you the security group. Okay. So on the Galera clustering, we have defined a security group. We have created a rule. Again, same. First, we're gonna create a custom TCP. Uh, uh, sorry, the SSH with the 22 port, 0.00 source security, and we're gonna create a rule. We'll go and edit inbound rules. 4567 custom TCP, 4567 custom UDP, 4567 custom TCP. Oh, sorry, I already mentioned, and 4444 for custom TCP. We're gonna select this. It's already given on the documentation, official guidelines, right? Then this is how the security groups look, right? And then you're gonna set your three instances, you're gonna name it, and then you add it and make it as cluster A, cluster B, and cluster C. Again, same process. You're gonna select key pair walkie, existing security group, which is the Galera one, right? And then this is how it will be created. Then you go to your list your all the files, and on now instead of going to that 50 dash server, we're gonna go to 60 dash Galera, and on that we're gonna make two changes. First, okay, we'll have to uh, e- in the respect cluster address, we're gonna have to add all the three IPs, right, separated by commas, which is our first primary private IP, second cluster B, and third. Okay, all these private IPs will have to mention, and then we'll have to add a line for the WRSP provider, and this line will have to add. It's already given on the documentation. And then on each node, we're gonna disable MariaDB, stop MariaDB, and we're gonna start MariaDB. So you can see on the cluster A, right? I have performed this, then I have stopped, right? And then I have added Galera new cluster, right? On the cluster A, then into MariaDB, I have tried to check the status. Again, there was some configuration error on my cluster B file, which I have corrected afterwards. And you check your status for a cluster size, it will show like 3 cluster, right? So that has been done, right? So once it will gonna show all the cluster, after you start your MariaDB, right? Then we'll have to perform cluster operation and testing. So the first part is data consistency validation across nodes, run on all three nodes, and we're gonna compare our result, right? So let's go and perform the operation. So the first I have select all the counts, right? Record count validation for categories, suppliers, product, customer, order, right? And you can see like on first cluster A, cluster B, right? And cluster C. All the counts are matching with the timestamp. You can see 21, 31, 43, 21, 31, 16, and 21, 30, 23, right? Just like after 20, 30 seconds delay, all the counts are matching. Then we're gonna perform some insert update and delete. So I have from insert on the cluster A, right? And soon as do select from, you know, that product ID, right? I can see that, yeah, new product ID has been created. And I'll check over here as well. It shows, yeah, 299.99 with the product ID Galera taste product on node 1, which I have created. It's showing on node 2 as well, and it's showing on node 3 as well. So that means it is working correctly, right? Now I'll gonna perform some update and delete as well, right? So let's say on some other node, uh, again on the same node, I have node A, I have perform update. So instead of set price 299, I have updated to 399, and you can see now it's showing 399 on cluster C, and it's showing 399 on cluster A as well, right? So I updated on cluster B, and it's showing on cluster A and cluster C as well, right? Now let's say we perform something on cluster C. We have deleted one, product from the products table, and it has been deleted. Remaining test product 0 on cluster B, and it's on cluster A as well. So all our primary, we can perform anything on any cluster and it will update on all three. Okay. Again, I have inserted on cluster A, right? And as soon as I do select, okay, it shows on uh, like node 1, it has updated on node 1, node 2, node 3. Like on node 2, I have inserted 2, so that's why it's showing 2, but it's basically showing on all the three nodes, right? So yeah, let's go to the documentation. So I've shown you real-time synchronous replication testing, that if we write on one node, it will verify immediately on other nodes as well. Insert update delete has been done, right? Then multi-node concurrent writes. So on node 1, I have inserted customer. On node 2, I have inserted customer. And on node 3, I have inserted customer. So this is, I've already shown that it's showing that it's inserted on all the three nodes. This is for customer, right? You can see on all three nodes. On node 2, I have inserted two customers. So simultaneously it's showing for all the three nodes. It does insert it. Okay. So yeah. And part 5 is basically we are adding a new node to a cluster. Okay. So we're gonna install MariaDB server on that new node 4 and Galera as well. We're gonna configure our galera.cnf file. We're gonna add our fourth IP address separated by comma, right? We're gonna stop MariaDB, start MariaDB, and then we're gonna verify. So it should show a value of the cluster size is updated to 4. Okay. And then we'll again gracefully removing the node again from the cluster. So remove a node from the cluster. We'll just gonna, so you can see I have created a cluster 4 as well, right? Cluster D. We're gonna remove that cluster, so we're gonna just stop MariaDB over there, and it's again updated count back to 3. Before that, I have also performed whether on cluster D, if I perform operations, does it working or not. So you can see I have performed some operations. It does showing over here, right? Like some basic select operation, that means on node 4 as well. Also it's working. So yeah, you can add as many cluster as you want. Then again over here also we have did a failover testing. So the scenario one, if let's a single node fail happen, then we're gonna check our initial cluster state on all nodes, right? It does show 3. Then we're gonna stop MariaDB. It updated to 2. Okay. And then we're gonna test our write operations on node 1. Okay, let's go back and I'll show you. So cluster size was 3. Okay. And you can see I have stopped on one of the cluster and cluster size is updated to 2. And then I have inserted over here. Okay. And I have did I have inserted over here. Okay. And if you check on any other cluster, it does show that it inserted over there as well. Probably on over here. Yeah, this one. During node 3 failure, it does show that it's updated over here as well, right? So even if it's node 2 not running, I update on cluster A, it updated on cluster D as well, the node 3 failure one, right? Yeah, node 3 failure, right? Then I have did uh select. Okay, so basically I have performed a write operation to verify, right, that select star from products where product name is equals to during node 3 failure, and then consistency validation after the operations. So like we can match the record counts on both the cluster. Okay, so you can see over here the record counts are showing, right? Product 52, customer 100,004, right? Whatever. And then you can see 52 and 100,004. So it is matching on both the cluster as well. Okay. And then yeah, what we have validated is basically in Galera cluster, like clusters as verified on all 3 nodes. We have successfully loaded our data across nodes. We have matched our record counts. We have inserted, update, delete. We have performed complex transactions on new node. We have added successfully. We have removed the node as well, right? And then on even if single node failure happens, like our data consistency remain across all the nodes as it is. Okay, so those are our validation results. Let's go back to a ppt. So yeah, Galera cluster overview I already explained. The multi-node real world example I already given you, that let's say during a tag week, right, campaign, simultaneously product addition occurred. So the Sarah product team uh, like adds a new AI powered vacuum, and the marketing team inserts new products bundles for ad campaign, and David updates supplier details. So like Galera outcomes will all operations process concurrently across different nodes. Cluster resolves conflicts automatically and synchronize instantly, and no data interruption or write has been observed, right? So those are the demonstration of Galera, which means it's truly multi-primary capability, and it's really crucial for AetherMarts, like across team workflows, right? So yeah, let's go to the key advantage and disadvantages, okay, for the Galera. Oh no, it's explained like addition and removal, so which I already explained you and we have verified as well. So let's go to the validation of results. So what we have validated is basically validation was done through SQL testing on both the servers. We ran record counts, checksum validation, and insert, update, delete replication test to ensure the data consistency. The results confirm that replication worked correctly and both server has identical data sets. Okay. And there was 99.8 uptime on replication, but 100% tested on Gorilla cluster. And yeah, that's what mentioned over here. Now about advantage and disadvantage. So yeah, like which moving on Galera clustering, which offers synchronous replication across all nodes to stay perfectly in sync. There will be zero data loss, multi-master capability, so all nodes can handle reads and writes, automatic recovery and failover. And disadvantage will be like higher write latency due to synchronous commits and complex setups, tuning also required. It does works based in low latency network, so in high latency network it might does not work as consistent, right? For ethermat, Galera is ideal for critical functions like orders, payments, and inventory management, where consistency is more important than the row speed, right? But still I think if we use like a recommended, I recommend hybrid replication strategy. Why? Because like if we use a hybrid architecture, it implement asynchronous replication for analytics and backups, and Galera clustering for core transaction systems. So this provides for based both workloads, like it will perform scalability and fault tolerance as well. So that's what mentioned asynchronous replication and synchronous replication overview, right? Then outcome, it combines speed plus reliability, and it satisfies Alex uh, no single point of failure goal. It meets Sarah's 24/7 uptime requirement. So all stakeholders' requirement has been satisfied. That's why the hybrid implementation is the key takeaway. And yeah, asynchronous for scale and synchronous for trust is our learning. Finally, so what we have learned basically is throughout this milestone, I think I gained hands-on experience in configuration and testing of replication and clustering, performing failover recovery and consistency validation, understanding of the trade-offs between performance and consistency. Additionally, I also implemented base scripts and SQL-based automation to streamline, like monitoring and testing as well. And if I talk about from a business standpoint, Ethermite now has a cloud-ready, AI-compatible, and resilient data backbone. So yeah, that's important, and that's how it does support for next phase of growth. So it and that's the next strategy for Ethermite or any kind of businesses, right? Yeah. So conclusion and the AI disclosure basically. So conclusion I'll do first, like the milestone successfully implemented and validated two highly availability architecture. First, standard application for again read, scalability and backups, right? Used for analytics, and Galera clustering for real-time consistency and fault tolerance, ideal for continuous online operations. Again, it verified zero data loss, automatic recovery, and consistent performances, and both systems were thoroughly tested for failover recovery and data integrity as well. So yeah, we have not done vector support, but like positioning Ethermart for next generation AI feature as well, which we'll probably do in the next milestone. So yeah, this announcement prepare Ethermart for enterprise level growth and like intelligent AI driven operations as well. Like it will make intelligent database ecosystem ready for the future growth, right? So AI disclosure very important. I use ChatGPT 5, and Cloud AI because needed scripts for the SQL code testing, like what type of operation should I perform for validation, records count matching, insert update delete, failover testing. So for that I did took some help. I took some help from Cloud AI, and it assisted with me for the SQL, script drafting, configuration, syntax verification, and some document refinement as well. And yeah, all outputs were manually validated by me and debugged for the accuracy, right? That demonstrates how AI can accelerate your database administration task, when you combine with the domain expertise as well. So yeah, compatible with MariaDB, and that's how domain knowledge has been tested. Okay. So yeah, thank you so much for listening and giving attention. I'd be happy to answer any questions or dive deep into your configuration and testing process. If you have any follow-up questions, you can reach out to me on darshil.vaijada@tamu.edu. Thank you so much once again. Bye bye. Have a nice day ahead.